So in this lesson, we're going to learn how to solve radical equations algebraically, and hopefully you watched the video on how to solve them graphically first. So first of all, what is a radical equation? And I want you to take a few seconds and take a look at these six equations and think about which one do you think is the radical equation, or some of them are radical equations. Maybe all of them, maybe none of them. So if you think that all of them are radical equations, let's look at the definition and let's see if we're correct. A radical equation is an equation that contains a radical expression with a variable in the radicand. So this is the key thing, the key part of the definition. You have to have a variable inside the in the radicand, which is the expression that's inside the radical bar. So for example, what we're going to do is we're going to sort these out, and we're going to have radical equations and not radical equations. So in this equation right here, we have 3 in the radical and the variable is not inside the radical, so this would be not a radical equation. For this equation, we do have x in a radical, so it will be radical equation. So with this one, and so with this one, all of these are going to be non-radical equations because x, or the variable, is not in the radicand, so it's not underneath the square root bar. So all of these, although they seem like they should be radical equations because you see radicals in them, are not, because the variable itself is not in the radicand. Alright, so the first thing I want to do is I want to remind you how to solve equations like this, which were quadratic equations, and we solved them in the last chapter, chapter 10. So the way we approached it is we said we should isolate x squared first. So what we did is we divided both sides by 5, and we got x squared is equal to 4. And then we took a square root of both sides because we wanted to cancel out the square, and we remember that square root, taking the square root and squaring something are two reverse operations, and we got two answers. We got x is equal to negative or positive 2. This is the key thing that's going to help us here. The fact that squaring something and taking the square root are reverse operations are going to help us in this chapter, because instead of trying to get rid of the exponent, we're going to try to get rid of the square root. And if taking the square root of x squared gives us x, or plus or minus x, we're going to get x out of a square root by squaring. So this is going to give us x. Alright, so here's our first equation. And what we're going to do is we're going to isolate our square root of x here first. So we can divide everything by 2, and we get square root of x minus 4 is equal to 0, and then I'm going to add 4 to both sides, and we're going to square the left side and we're going to square the right side, and we get x is equal to 16. Now some of you might have would want to use a different approach, and instead of dividing through by 2, maybe you want to add 8 first, which is also good. The equally correct methods. You would get the same answer eventually, just a little different steps. So if you added 8 first, you would get 2 square root of x equals 8, and then you can divide by 2, which would give you a square root of x is equal to 4. And then, to cancel out the square root, you would square both sides, and you get x is equal to 16. So either method is good. This is the new thing right here. So once you isolate the square root of x, how do you get rid of it? The square root, and you get rid of it by taking squaring both sides. So if you remember from the graph, sometimes we have no solution, sometimes we have one solution or 2 solutions. So it's always good to check by substituting the answer back into the equation. So we're going to go back to the very original equation, and we're going to substitute in 16 for the x to make sure that it actually works out. So 2 times 8 minus, just kidding, because square root of 16 is 4. So 2 times 4 minus 8 is equal to 0, and it works out because we get 8 is equal, 8 minus 8 is 0, so we get 0 is equal to 0. So we're 100% sure that our answer is correct. Pause the video and try these two examples to see if you understood example 1. Alright, so the two answers that you should get for part A, you should get x is equal to 49, and it is the correct answer because when we check it by substitution, we get it to work out. And in part B, we have an answer of x is equal to 1 over 16, and it also works out. Over here, I can imagine that some of you may be confused about how to get 1 over 16 when you square 1/4. Just remember that if you're squaring something, you can always rewrite it twice and get the answer that way, if you for some reason forgot how to square a fraction. Alright, so this example is definitely a little bit more complicated. We are going to try to isolate our square root, which is right here. And right now it has a plus 12 and it's also multiplied by 4. So the first thing I'm going to do is I'm going to subtract 12 from both sides, and I get 4 square root of x minus 7 is equal to 16. Then I'm going to divide both sides by 4. And remember, we're trying to get the square root by itself, so we can square both sides. Is equal to 4. Now my square root is all by itself, and I have 4 as my answer. So I'm going to square both sides, and my square and my square root cancel each other out. So I just have regular x minus 7, and it's equal to 16. And now I'm solving for x, so I'm going to isolate the x. And we get x is equal to 23. Now, as always, we're going to go ahead and we're going to double check. So we're going to take our answer and we're going to substitute it back into the equation. So we have 4 square root of 23 minus 7 plus 12. And 23 minus 7 is going to be 16. So we get 4. Square root of 16 is 4. Plus 12 is equal to 28. 16 plus 12 is equal to 28. And we get 28 is equal to 28. So that is correct. Okay. So sometimes you have it a little easier because this actually requires even less work. If you have a square root of an expression equal to a square root of another expression, and there's nothing added to the square root or multiplied, it's just square root equals square root, all you have to do is square both sides because you just need to get rid of the square root. And what we're going to get on the left side is 3x minus 17. And on the right side, we're going to get x plus 21. And we have to solve. So now what we're going to do is we have to move all the x's to one side and all the numbers to the other side. And I usually choose the side that has more x's. So in this case, I'm going to move my x's to the left side. And I'm going to do that by subtracting x. And I get 2x minus 17 is equal to 21. Then I'm going to add 17 to both sides. So we have 2x is equal to 38. We're going to divide both sides by 2. And I get x is equal to 19. And that's my answer. Hopefully, we're going to confirm by checking. And we're going to check that square root of 3 times 19 minus 17 is equal to square root of 19 plus 21. We'll do the right side first because it's a little easier. So here we get a square root of 40. And 3 times 19 is going to be 57. And 57 minus 17 is also 40. Now you don't actually have to simplify this because once you get here, clearly square root of 40 is equal to square root of 40. So you can stop right here because we're done. We confirm that our left side and our right side are equal to each other. Alright, so pause the video and try these two equations. Try to solve these three equations to see if you understood the last two examples. Alright, so the three answers that you should get are going to be x equals 30, x equals 5, and x equals 1. Okay, so sometimes we get extraneous solutions, and that results from squaring both sides. It's possible to get two solutions that don't work at all. It's possible to get one solution that doesn't work, and I'm going to show you in a second how this can happen. So just think of an equation like this. So square root of x is equal to negative 5. So clearly this could never happen because square root of a number can't possibly be equal to negative 5. But if you square both sides, that negative completely goes away, and we're not actually going to realize that there's no solution. So you would have, your solution would be 25, which is an extraneous solution because it's not actually a solution. So when you go back to check your answer, you get a square root of 25 is equal to negative 5, which is not true because square root of 25 is just regular 5. So this would be an extraneous solution. And this is where the graphing comes in handy, because let's say you think you have an extraneous solution and you're not sure. If you just imagine what the graph looks like, so this would be a graph of square root of x, and here would be a graph of y equals negative 5. Hopefully you could see that they would never intersect, which means that there would be no solution. So as you're solving, you expect to get no solution even if you get an answer when you square both sides, because that answer doesn't actually work. So graphing is a great way to confirm that you have extraneous solutions. Alright, so in this example we have a square root of an expression equal to x, so what we're going to do is we're going to square both sides to get rid of the radical. And the reason why I'm squaring right away is because my square root is already isolated. So we get this. And this is a quadratic equation. And remember, we could solve quadratic equations using factoring, completing the square, using the quadratic formula, taking the square root of both sides. In this case, we're going to try factoring. And in order to use factoring, I have to set everything equal to 0. So I'm going to keep my square root positive. My left side will become 0 because everything would cancel. And I have x squared plus x minus 6. And this is a trinomial where the two factors would start with x because I have x squared. And then I need to find two numbers. They need to multiply to negative 6. But they need to add to 1. And our two numbers would be 2 and 3. And because they're adding up to a positive 1, the 2 would be negative. So I have negative 2 and positive 3. And to solve, you take each factor and you set it equal to 0. So you take x minus 2 and set that equal to 0, and x plus 3 equal to 0. And you get one solution where x is equal to 2, and you have the other solution where x is equal to negative 3. Now we're going to double check both of them, but before we even check, this is where the graphing could be helpful. So, we actually never graphed the one with 6 minus x. If you try to plug in some points, you get, at 6 you get 0, and when you plug in 5 you get 1, so it actually goes backwards. And when you plug in negative 3 you get 3, so it actually looks like this. And my y equals x is in line with the slope of 1 and y-intercept of 0. But you could see that they only going to intersect in one place, and basically we just have one solution. So when we check, I'm going to pause the video and check. So when I check my first one, x equals 2, and that's the one I'm expecting to work because of the graph, it works, and then this one doesn't work. So my only solution is x equals 2, and this is an extraneous solution.